Hello. In this video, I will show you how to make a project which will control multiple LEDs to blink multiple patterns using Raspberry Pi and Python. I think this may be of particular interest to you if you are looking for a project idea for your high school or grade 8 science class. This project is fun to make, it is interactive, and it will show really well. I would categorize this project as medium difficulty and would say that you should only attempt it if you have some prior experience with a breadboard and with writing Python programs for the Raspberry Pi. If you are a beginner, you may be better off making something simpler, for example my basic LED blinking project. But if you're up for a challenge, you are welcome to stick around and see how it's done. The interactive portion of this project consists of a button which changes the pattern with each press. My project has 6 LEDs, which I consider the minimum. I suggest expanding it to 8 or more LEDs. The more LEDs there are, the better this will look. Here's what you need. Obviously, you need a Raspberry Pi. Any model with a 40-pin GPIO will do. You need a breadboard. I strongly suggest getting the cobbler connector with the ribbon cable. Building this project using individual wires would be very difficult, not to mention it would not be portable. You need some LEDs, any colors, whatever you like. Also current limiting resistors, one for each LED. I will be using 220 ohm, but you can go higher to 330 ohm, especially if you are planning more than 8 LEDs. Without the correct resistors, depending how many LEDs you will have, you may draw excessive current from the Pi. The total maximum for all LEDs combined should not exceed 50 milliamperes. You will also need some jumper wires and a push button. Any size button will do, but a larger button is easier to use when demonstrating a project. Putting the breadboard together took me a while. Be prepared for that, especially if you want to make it look good. If you want to arrange the LEDs in a nice circle, it may be helpful to make yourself a cardboard template. I use a hole punch to form a hexagon shape. If you are planning to display your project and have other people interact with the breadboard, I strongly suggest using flat jumper wires and to insulate the resistor wires. This way accidental shorts are a lot less likely. You may also consider shortening the LED legs too. I try to keep my circuit small. This is why you see me even running some connections under the cobbler. My button is in an unusual spot. Most people place buttons in the middle of the breadboard, but I have plans to expand this project and need this breadboard space. This is why my components are a bit cramped. Avoid using long jumper wires. A breadboard full of crisscrossing wires looks sloppy, but most of all, it invites all kinds of trouble with broken connections later. No reason to ruin your presentation that way. My go-to library for GPIO programming is GPIO 0, which yields very elegant and simple code. The LED pattern will be shown continuously using an infinite loop, and such loops are best to be run as a thread. The sleep function will control how fast the pattern moves around. For this project, I will place the LEDs in a list where each of my LEDs will be referred to using a numerical index starting at 0. This will make it easy to go through them in sequence when turning them on and off. Python lists work similarly to arrays, which you may be familiar with from another programming language. The numbers such as 20, 21, 26 associated with the LEDs refer to GPIO pin numbers as shown on the schematic diagram. The isRunning Boolean variable will control whether the pattern is being actively shown, while the delay variable will control the speed of the display. The smaller the number, the faster the display will be. The pattern will be specified as a list of binary values, zeros and ones, with 0 being off and 1 being on. The pattern has 6 values equal to number of LEDs. If your project will have more LEDs, you will need to adjust that so the size of the LED and pattern list is the same. Since I'm planning to add more than one pattern later, I named the list plural as patterns. In this initial pattern, only one LED will be active, starting with LED 0. Pattern rotation will be a continuous process where the pattern numbers are shifted. The two variables, LED in and LED out, specify the parameters of that process. Initially, the list will be shifted to the left, which will result in the pattern moving counterclockwise. The main portion of this program will go into a function called showPattern. It will be essentially an infinite loop that will continuously turn the LEDs on and off based on the active pattern. The sleep function used here controls how fast the pattern travels. Whether a specific LED is on or off is directly tied to the corresponding pattern item. For example, LED 0 will be on where item 0 in the pattern is equal to 1. I could just add 6 lines of code similar to the following, but using a loop for that is a better choice. The pattern needs to be shifted after all LEDs have their values set. This is a two-step process. Initially, the first pattern item, which is a 1, gets removed from the pattern. With this item removed, the remaining pattern numbers move to the left. Then the item that was removed gets tacked on at the end of the shifted list. After a small delay, all LEDs are processed again, but now following the shifted pattern, and so on. This is almost done. The showPattern function will run as a thread using standard threading syntax. Using a thread makes it possible to expand the project later and to allow other code to run concurrently to the LED display. Code under the finally is executed when the program ends. This is the place to stop the display by changing the loop control variable to false. A small delay will allow the last cycle to finish before the program ends. The last thing to be done is the activation of the LEDs. This way the GPIO pins get restored to default, which is standard practice. The program is ready, and after setting permissions, it can be tested. You can see the pattern moving as intended, counterclockwise. The next step in this project is to program the button so whenever it is pressed, the pattern changes the direction. This part is very easy. An additional input from the GPIO0 library is needed. The button is initialized with the GPIO pin 16 as connected on my breadboard. I need to register an event for the button. When pressed, it will call the change direction function, which I will write next. The LED in and LED out variables will be swapped in this function. Python makes swapping variables very easy. Here's the updated project in action. The last thing I want to add to this project is multiple patterns. The button, other than changing direction, will also switch the pattern at the same time. You can have many patterns, but this largely depends on how many LEDs you will have. The more LEDs, the better, subject to the number of available GPIO pins and your breadboarding skills. The pattern list needs to be expanded. Now it will contain multiple patterns. They will all follow the same format, and I will make 6 patterns. I would like to activate the patterns in random order with each button press. The runRange function will give me a random index within a specified range, and I will use that index to access a specific pattern out of my list. The len function will automatically provide the count of the patterns as an alternative to hard coding a number such as 6. This way, this line does not need to be adjusted if I add more patterns later. I will also add a line to make sure that the pattern is randomized every time the program is started. One more change needed. Now I need an extra set of square brackets with the pattern list. The index used in the new brackets refers to the pattern itself, which one it is. Let's have a look how that works now. Pattern 0, pattern 2, pattern 3, pattern 2 again, pattern 4, and so on. With a small number of patterns, there's a chance to get the same pattern twice or even 3 times in a row, although it would be in reverse direction. This can be prevented by a simple procedure where a new index is generated, but is only activated if it's different than the current one. Otherwise, a new index is generated until a non-repeating index is found. If you are preparing a project for a demonstration, it may be worthwhile to configure your Pi to start your program automatically on boot. This way, all you need is to connect the breadboard and power and be ready to present without connecting to the Pi over Wi-Fi to start your program, which may not be even an option at that time. For that, you need to add a line to the etc. rclocal file using a text editor, specifying the path to your program. For example, this is how I would set it up for this program. You would need to change the path to match the location and name of your program. Make sure to test it by rebooting the Pi. With this in place, your program will be started automatically every time you power on your Pi. To stop that, you need to kill the program first and then remove the line you added to rclocal. That concludes this tutorial. I would love to see how you implemented your project, especially if you used more than 6 LEDs or added more features. Feel free to post a short clip as a comment. Thanks for watching.